So this is a pre-recorded talk, but I'm available when it's running to take your questions and engage on the topic that I'm discussing. So my name is Samuel Kihahu. I currently work as a DevOps engineer at a company called Tala. Tala is a financial services company that whose mission is to provide financial access, choice, and control for the underserved in the society. We are currently based in 4 countries: Kenya, where I'm based, India, Philippines, and Mexico. So I'm going to be talking to you today about testing infrastructure as code on your local host. And the agenda for this talk is on why you would choose to test on localhost, what kind of tests that can you write, what tools you can use, how you can use those tools, and what lessons we've learned as we've worked with this workflow. So why test on localhost? So one of the reasons that would put across is the speed. When you're testing on your local machine, you don't have to work with the lag of a request going all the way to the cloud and coming back to your machine. You're able to iterate faster with your changes and fix issues quickly. Another reason is on cost. It's simply free. You just have to work with the machine resources that you have with you. Another reason is the convenience that you get because you're working with an environment that you're familiar with. So if you run into issues, you're able to easily troubleshoot and get the root cause. Another reason I would put is fail-safe. You're not afraid to experiment and break things because you're actually not interacting with the cloud when you're testing locally, and you're able to validate the changes before you eventually push them out to an actual cloud environment without fear. So for us, when we were exploring this workflow, we chose two tools. One is a Go library called terratest. And the reason why we chose terratest is we previously used a tool open sourced by the same organization that released open sourced terratest called Grantwork. And we had a good experience with it. A colleague of mine had used it to manage part of our infrastructure as code, and we were confident to use it for another of their tool for another project. Another thing we discovered as we were getting into we were evaluating the tools is we realized that it not only supports testing Terraform, but you can actually test other tools like Kubernetes, Helm, Docker, even Packer. So we could leverage the learnings that would get from testing Terraform code into other tests that would write for other components. For localstack, this was simply because our current production workloads run on the AWS cloud, and localstack supports AWS cloud. What tests can you write? So for the particular project that I'm describing, we chose to write 2 kinds of tests. These are unit tests, where we were testing whether individual resources could run could be created in isolation without any errors. We also wrote integration tests, where we were testing whether 1 or 2 or more components could be created together with dependencies without any error. So the project I'm describing that we used to experiment with using terratest and localstack was meant to allow developers to create some of the common resources that they require while doing their development. An example being SQS or SNS. So the complexity of the modules wasn't much. So these 2 tests were sufficient. So this is an example of a terratest test. So the terratest leverages or is built on top of Go testing package. So we inherit or we use the Go testing package whenever we are writing the code. So in the import, we'll import the package that comes with terratest, and then underneath it's riding on the Go testing package. And the Go testing package supports testing in parallel. And another thing we learned, or one of the things we learned when we were writing this test is the need to randomize the naming of your resources, because we realize that if you name them without unique or random identifiers, it would be possible eventually when you run the tests on an actual cloud to have collisions in terms of the similar namings. Terratest also supports, I would say, helpers that allow you to interact with the various SDKs for the cloud providers. And in this instance, since you're using AWS, you're able to get helpers like getting a random stable region. So when you create a resource, you're able to randomly choose a region from a list that's provided by terratest in the backend. The way you'd pass options to terratest and interact with Terraform is through this options tract in the Terraform package. And some of the configs that you can pass to it is the path where your Terraform code is located. So in this example here, the code is located one directory above where this test is located. You can also pass variables. So in your Terraform code, if you expect a variable, in this instance, you have a variable named name, you're able to pass that variable using this option. You're also able to pass things like environment variables. So this is an example, is this random AWS region that we got. We're able to pass it as an environment variable to the Terraform that's going to be running underneath. As I said, we chose terratest because of the helpers that it has. So for the Terraform package, you find it has .destroy, and we run this as a defer so that eventually it will run as the last function or method and cleans up your environment once you've finished creating your resources. We do an init. When you're running Terraform on the CLI, you do a Terraform init and then Terraform apply, but the Terraform package comes with an init and apply method that allows you to combine the two. So in the SQS Terraform code that I'm referencing here, I have an output that I expect from as an output from that apply. So I'm able to use assert to validate that the naming that I gave and passed as a variable is actually what gets created as an output. So you're able to validate that the code actually does what it's meant to do. And then you're able to delete the resources. So one thing I'd mention is the Terraform package comes with these methods, but also supports so an example is this destroy. There would be an accompanying method called destroy and then capital E, which means it returns an error. So if you choose to use that method, you'd need to handle the error code that is returned if there's any issue that happens when the tests are running. So just something that you should be aware of when you're using terratest is that you have the option to use the error returning methods or just the methods that handle the error for you directly. And as I mentioned, since we are riding on top of the Go test package, we need to follow some of the rules for writing Go tests. So an example being following the naming convention. And as I mentioned, the file name needs to end with an undertest.go. So this is the command that you'd use to run this function. So I noticed I had two example functions. So this is testing the SNS, but if you wanted to test the SQS, you'd change SNS to SQS. On the local stack configuration, since we are leveraging or we are testing an AWS provider, would just use the normal Terraform provider, but then would need to make some changes to the options or the configurations that we set up. So you notice I have just an access key and region here. So you have the option of setting this, and you can even just put for the access key and the secret key, any text would do. And then we skip the validation of the credentials, and we don't validate the API also. So you also need to configure the endpoint. Since we are using the local stack, we need to configure the endpoint for the service that we want. So if for SNS, so when local stack starts up, it starts multiple services running on your local host, running on different ports. That's why for SNS, we need to configure a different port. For SQS, we need to configure a different port. So there is an update in local stack where they've introduced this edge service running on port 4566, and it's supposed to proxy all traffic to other resources or services. So if this is active, you would just have edge configured, and you don't need to configure SNS or SQS. Now, currently this is not supported by the Terraform AWS provider. So there's an open issue on the GitHub repository for the Terraform AWS provider. So eventually, when that gets implemented, it will be possible to use this. So I mentioned here that when you eventually start running your tests both on localhost and also on the cloud, you might want also to use Terraform's aliases, where you are able to configure multiple similar providers, but then differentiate them using aliases. So you'd have a provider AWS, that's the default, that actually talks to the cloud, and then have a provider with an alias that will talk to local stack. So, and you're able to pass via config inputs to determine whether you want to run the test on actual cloud or on local stack. So local stack is a Python module. You just do pip install local stack and do a local stack start. So I'll be doing a demo at the end of this presentation. Some of the lessons that we learned as we were experimenting with this workflow. So one of the lessons is that there's limitation in terms of scope when especially using local stack, because you can only be able to mock out the AWS cloud. Other providers are not, or other clouds are not supported at the moment. And even when I looked at the roadmap, I didn't see any roadmap items for supporting other cloud providers. So if you're not using AWS cloud, local stack might not meet your need. Another lesson that we learned is, as I mentioned, Terraform provider or local stack depends on the Terraform AWS provider, and they currently at the moment just provide best effort support. So that example I showed you previously of the edge service, this edge service is currently not upstreamed. So you would have to, there are some features that might not be immediately supported. Another lesson that we learned is on the limited functionality. When you use local stack, they only offer a subset of services. I've linked a link here where you can see all the services that are provided with the open source version. So they do provide a commercial local stack pro, which has more services for AWS that you can mock out. But if you're just going the open source route, there are some services that you might not be able to test using local stack. Another lesson was on the CI integration. So when we are writing our tests, and as we wrote more modules for various resources, it became necessary for us to start considering either using tags, which terratest supports, or using an option for shorts. This is an underlying package feature for the Go testing package, or using makefiles. So we chose for us to use makefiles, and the reason why I'm highlighting this is maybe you have, let's say, 10 tests, and you just want to run a subset of those tests. When you have tagging, or you're using the short option, or using a makefile, you're able to choose and pick which test you want to run. So it gives you that flexibility. Another lesson is on, as I mentioned, when you eventually want to run tests both on localstack and the actual cloud, you want to start using the provider aliasing so that you're able to switch between the two. Another lesson is on long-running tests. So by default, terratests time out after 10 minutes. So if your tests take longer, you want to extend the default using the timeout flag, especially if you're using a CI that would be affected by a timeout of a particular set of minutes. You would want to extend this. So another thing I mentioned when I was describing the sample terratest test is on the error handling. The fact that the Terraform package comes with methods that both handle errors internally and ones that return errors, and for you to decide to handle them. So when you're writing your test, you need to decide whether you want to do the error handling yourself or to use the methods that actually handle the errors. I mentioned about using unique naming of resources so that you avoid collision. So when you're creating the resources on actual cloud and the naming is not unique, you stand the chance of erroring out because of collision of naming. Finally, there's caching. So by default, from GOP 1.10, caching is enabled by default, and it means when terratest runs, it's not going to run the test. So you need to disable that cache if you want to run the test every time. So just a recap of the presentation. Testing locally is cost effective, is fast, is convenient, and allows you to build confidence before you eventually start running your tests on actual cloud resources. But there are limitations, and these are mostly related to cloud provider support and also functionality support. You can be able to do both local testing and testing on the cloud by leveraging Terraform's aliasing, so that you're able to switch between testing locally and testing on the cloud. Some of the references that I have is a great talk by the people who've outsourced terratest. So there's a link to that. There's also the config for setting the aliasing that I talked about that would allow you to test between localhost and the cloud. There's also a link to the config for providers, for custom providers. And then I have a link to sample modules that I have to run or to do the demo for you with. So I'm going to switch to my terminal so that I do a demo. So as I mentioned, you start localstack by doing localstack start, and you can enable debug option if you want to see more logging. Sorry, localstack start. So in the background, localstack starts a Docker container. So if I do a Docker PS, I'm able to see there's a localstack container running. So if I just navigate to my repository, so this is what is I linked on the last presentation, where you can go to my GitHub and access this code. So this is a simple code that just creates resources for SQS and SNS. And I've created a tests folder, and inside the tests folder is where I have the file that has the tests. So if you just look at the file, this is what I was saying. You import from terratest. You're able to import various packages that it comes bundled with. So this is the example I had for testing SQS. And as I mentioned, it's running in parallel. These are randomly named name. These are random region. And there's also the options that I pass to Terraform. So I'm going to run this example, and the way I would run it is go test run SQS. So as this runs, just a reminder that if your tests are taking more than 10 minutes, it's going to air out. So you might consider adding the timeout flag here. So you can see right now we are creating the resource, and you can actually see these are the outputs. These are the outputs that the module creates. So maybe let me just show you what is inside SQS file. So it's just a simple module that inherits from the open source SQS module and creates a name from the input that I provide. And this is provided from the terratest code that I have. Yeah, so that's the end of the talk. So you can ask questions and you can chat when during the virtual meetup.